I'm Kevin Psychowski. Hi, everybody. I'm at the University of Toledo, and this is the Globe Mission Earth webinar. Let's share my screen. Oh, of course, I've been looking at radar, seeing the lake effect snow starting up, although they're predicting it not to get too bad near Buffalo until Thursday. All right, so this is our fifth webinar of the fall, I think. I might have lost count, but I think we're at 5. Globe Mission Earth is a partnership between University of Toledo, WestEd, Tennessee State, NASA Langley, Boston University, Berkeley. We use the GLOBE program, bringing the GLOBE program and NASA assets into different educational settings, K-12, the university, etc. And what I want to bring your attention to, so everybody knows, there's the GLOBE Virtual Symposia, and we encourage all your students to submit projects to it, and the deadline is March 1st. There's a series of webinars that have been going on, and they're archived, and you can get more resources on what type of projects. You know, they're basically your typical GLOBE project using GLOBE data to answer a question. And then you can also, your students can present at one of the regional, US regional symposia. The one in the Midwest is going to be May 18th and 19th at Wayne State. And you see the locations here. SUNY Fredonia. Mike Jabad is the professor there. I'm not sure what date that is, and he may be posting that. Let's see under chat. May 4th through 6th. All right, thanks, Mike. So I knew you would be right on top of things. And then you see some of the dates already picked out for other the regional symposia. Great opportunity for your students to present and meet kids from other places. And then don't forget the GLOBE annual meeting. It's actually not the GLOBE annual meeting this year. It's actually GLOBE Learning Expedition for students. So the focus is actually students and having students go. So there's going to be more students in Ireland this year than there have been in the last few years for GLOBE meetings, the annual meetings. And it's the week of July 4th. I think it's July 1st through 5th or something like that. And so if your kids can go to that meeting, that would be wonderful. I think they'll have a great time and learn a lot, and good for you too. So, all right, well, I'll stop there, and I'll turn the talk over to David. He's at Tennessee State. He's a colleague there, and just came in 3rd place in a half marathon. So he's an excellent runner as well.
Okay, good evening. Like I said, I'm David Padgett, Associate Professor of Geography at Tennessee State University and Director of the Geographic Information Sciences Lab. And so what I'm going to do tonight is try to show you some ways that you can use some of the, if you have some eclipse data laying around, you can perhaps still use it with geographic information systems, specifically ArcGIS Online, to do various mapping projects. So I'm just going to take us chronologically through the process that my students and I went through this year with the eclipse, as it was described in the description of the webinar. I'm going to be performing without a net, so we'll see what happens. So I'm just going to start off chronologically. Oops. I guess I should share my screen. Okay, I'm assuming everybody can see this.
Yeah, so it's the Stratford STEM Magnet High School.
So this year we worked with our high school partner, we meaning Tennessee State University, and so as an outreach activity for many years, my students have worked with high school students to encourage them to consider pursuing STEM careers and STEM education beyond high school. So Stratford is a high school in East Nashville. It's 100% free and reduced lunch program. predominantly students of color, predominantly African American, just the type of underrepresented group that we are trying to reach. Tennessee State University is a historically black college university. We have about 6,800 undergrad students who are about 95% African American, and a lot of them come from the same types of low-income backgrounds and moderate-income backgrounds as the students that we are attempting to reach. So this is sort of a near-peer mentoring, science education outreach type of project. This year, unfortunately, the eclipse didn't align with the local school schedule. So Stratford was not in session on August the 21st. So what we did was we had them complete this exercise. So some of my colleagues, along with our Globe teacher at Stratford High School, worked through this exercise prior to the eclipse. And so as you can see, the equipment included some GPS receivers, the globe cloud charts, thermometers, and a data worksheet that I'm going to show you in a moment. So we broke the students up into groups. Usually what I try to do is have one of my students be with each group. And then they went through, I'm not going to read all this, they went through this procedure where they basically collected globe-based data, but not specifically using the globe sheets. But you can easily convert the data from my sheets into the typical globe sheets that are used normally. And I'm kind of rushing through this because I want to get to the mapping process. And all of these materials can be made available after the webinar. And so this is the data collection sheet that we use. And so the students fill out these blanks. They have a very brief crash course on globe positioning systems that I present to the students just so they'll know how the technology works. And then we just go through the process of collecting the alcohol thermometer data and the surface temperature data using infrared thermometers. Land cover description, I asked them to record what type of surface it is. Is it asphalt? Is it grass? Is it in the sun or is it in the shade? So you get some variation of temperatures that they can observe. Then, of course, latitude and longitude using the GPS receiver. And then the typical globe data, cloud types, cloud cover, so on and so forth. So if you've already collected data, globe data using the formal globe sheets, you can easily enter the data into this sheet. And then the main purpose of doing so is to convert this into an Excel spreadsheet that can then be pulled into ArcGIS Online. And so because the Stratford High School wasn't in session, we decided to have them do a pre-eclipse exercise that Friday, and then my students on our first day of class engaged in this exercise. And so it was kind of a shock to the students to have to go outside. And so immediately on the first day of class, so again, I'm not going to go through all of these instructions, but essentially, in this case, we use the Globe Eclipse app on that day, and the students also, my students also collected data prior to the eclipse on surface temperature and atmospheric temperature and cloud data also using the basic globe cloud charts and the GPS protocol, et cetera, et cetera. So the ultimate goal was to be able to, in some way, shape, or form, compare the data that my students collected on the day of the eclipse with the data that the students at the high school collected a couple of days prior to the eclipse. And we were really fortunate in that the weather was pretty much the same on that Friday and Monday. It wasn't a perfect model, of course. In a perfect world, we would have had the data collection be simultaneous, or have them do the data collection together, but of course, that wasn't possible, Stratford not being in session. And so I'll just, let's go through here, just share with you a few of the photographs of us out. So here are my students. You see how excited they look and thrilled to be out there collecting data on the first day of class. This is the first day of class. And here we are during the eclipse. And that's not a great, I think I took those pictures during totality. And here's some more of my students out during the eclipse. There's the equipment and the GPS receivers and globe cloud chart. And so I was using an iPad to connect to the globe Eclipse app, and then there's the infrared thermometer. And so just there we are, just out on TSU's campus during the eclipse, taking observations. Just wanted to share those photos with you. So the result of our work outside was that we used the typical atmosphere, globe atmosphere, surface temperature data sheet to collect data outdoors. And so if you're familiar with globe, this is the typical atmosphere surface temperature data sheet, excuse me. And so using that sheet, we were able to look at the cloud data and surface temperature data and so on and so forth before, during, and after the eclipse. And so, and here is the, so I know this is very rough, but what we were doing was working together. And so my students were collecting data. This was a data collection sheet that was provided by Globe. And so I was trying to do 3 or 4 things at once, trying to collect data and get the data from my students, while simultaneously trying to log the data into the Globe Eclipse app. And it all worked out fairly well. Let me show you the, I'm sure this is familiar to some of you. This is the data sheet that was provided by Globe. And so, of course, our esteemed author there. And then here is the data. This looks a lot neater than mine looked when I was actually collecting the data. So the assignment that came along with the eclipse exercise was for the students, or my students, again, to collect the data. This is from the first day of class, and then take the data, enter it into the spreadsheet, into the sheet that I created, and then enter those data into a spreadsheet using these various column headings. And so let me just show you the data sheet. So here are the data sheets collected. Hopefully you can see that by each student on the day of the eclipse. So we were doing several things at once. We were filling out the globe sheets. I was recording the data using the app, and so on and so forth. But this just gives you an idea of how the students each participated in collecting the data themselves, getting the temperature data, the surface temperature data, and then I had to average all of these data together. We had a little math exercise because they had to convert these data into degrees Celsius, of course, and so on and so forth. on that day. So what we wound up with were spreadsheets containing the data that were collected. These are the data that were collected at Stratford STEM Magnet High School. So here's each group. Now, we were working with ninth graders who were a little bit rambunctious. And so notice that there is some missing data, but we got most of the data that we wanted to collect. And so what I'm going to do now is show you the finished product first, and then I'm going to do the high wire act using the pre-eclipse data from the high school students. So the main thing is that we do have the latitude and longitude here in this Excel spreadsheet. Again, this Excel spreadsheet was just converted from the hard copy sheets from the data collected in the field by the high school students. One thing that I will note is that if you notice here, if you decide to do this, these cells must be formatted as numbers and 5 places behind the decimal, or else this will not work. It might, so, okay. So now I'm going to close the spreadsheet and show you what the finished product looks like. So this is the finished product. This is, now this map was actually created by my students. So depending upon how advanced your students happen to be, they might be able to do this themselves. And so, here's the data that were collected at Tennessee State University, and hopefully you can see the legend here. And if you notice, they took temperatures during the eclipse and they overlapped it with time. And this could be a pretty good interactive exercise where you might click on a point here and the dialog box pops up, and you notice that the time 12:27 p.m. is approximately an hour before we had totality here. So we had totality at 1:27 p.m., or at least it started. And then you can make note of the temperature and surface temperature along with the time. And then we can compare that to perhaps, notice here we have a time that is after totality, and we notice that the temperature is several degrees Celsius lower. This is about 10 minutes after totality. And we might look at the land surface, but there are several ways that we can discuss what's happening at various points in time using your eclipse data, pulling them in the ArcGIS online. And so this is the final product. Also, here is Stratford. So this is so what my students did was they had our data, and then we also had Stratford High School's data. So this is the data that was collected a couple of days prior to the eclipse. And again, we just pull the data in, and we can look at the land cover and the temperatures. And so what I wanted my students to observe, of course, is, whether the temperatures changed before, during, after the eclipse. And in this case, we were looking at a day with the eclipse and a day without the eclipse that had somewhat similar temperatures. So there are just lots of jumping off points for discussion here. So what I'm going to do now is walk through how to get these data onto this map. And like I said, I'm performing without a net. This is step 1. So I'm going to go into ArcGIS Online, and I'm going to go back and get the Stratford High School data collection sheet. So we start off in Microsoft Excel, and we simply need to convert this into a comma delimited text file. So we select here, save as. So I'm going to save this as a CSV comma delimited file here. And so we're going to get all kinds of strangeness when that happens. Just hit OK. Yes. And then when I close it out, yes, yes. Okay, so now I'll go back into ArcGIS Online, and I'm going to zoom into well, I'm not going to zoom in. I'm just going to pull the points on into this map, and that. So I'm going to go to the add command, add content, add layer from file, and then I'm going to go to choose file, and I need to find that. It said perform without a net here. So of course.
Well, that's one of the hardest things is to find the file after you've saved it, right?
Yeah, I should have paid attention to where I saved it. Let's see, where is this thing? All right. Ah, goodness. Let's see this. Okay, where else? Oh, it's in there. It's in there. Okay.
Yeah, I think it's on the right side. It says Eclipse 2017 Atmospheric Data Collection Spreadsheet. Stratford HS. Is that the one?
Yeah, it's an Excel sheet. Let's see if that works.
No, I see.
I think I might have, I think I know what I did. I think I saved it. Ah, that's the right place. I'll put it somewhere where I know I can find it. I know where it is. Yes, whatever. Oh, okay. I see what happened. Okay. All right. Here we are. Let's see. Here it is. Open layer. So notice that I just pulled the data into. So this is Stratford STEM Magnet High School. Let me try to find a little bit more interesting base map layers that you can. Here's Stratford STEM Magnet High School. I'm going to change the so let's see, surface temperature, see degrees Celsius, surface temperature. And I'm just going to kind of rush through this. The main, there's lots of things that we can do. We can make heat maps and all that. We're not going to do that today. So there's the surface temperature in degrees Celsius. So these are the locations where the students went out on the schoolyard. Now, in order to bring in the second layer, it's kind of funny because you have to go back in and add layer from file and bring the exact same file back in, but then in doing so, I'll have to point to the thermometer temperature, and then we have to play with the play with the colors of the symbols. Hopefully that'll do what I wanted to do. And then the transparency is okay. I'm not going to fool with it. And so as you can see, let's go to legend. Anyway, so as you can see, that didn't work exactly how I wanted it to. Let me go back in. Okay, it's just being really, really, really uncooperative right now. So I'm going to try to change the size of the symbols and the color again. All right.
So what David's doing is he wants to show the surface temperature on one legend and the air temperature on the other legend.
Goodness, here we go. All right, so then I'd have to go in here and rename this to something. I hope I'm guessing right. So if you look at this point here, for example, okay, so this is, so the surface temperature is 34 degrees Celsius, and a thermometer temperature is 37 degrees Celsius, which makes sense because it's over grass. So this just shows the effect that the grass surface has, as opposed to, or as the anthropogenic surface has, as opposed to the natural surface. But if we look at this point, you'll notice that, there was one group that pointed the infrared thermometer at a lamppost, a metal lamppost, which was great. And you can clearly see that based upon the symbology, clearly the surface temperature is approaching 50 degrees Celsius. So the red symbol is much larger than the brown symbol, which represents the atmospheric temperature. And so you can clearly see the difference here in terms of, or you can clearly see the effect of the metal versus the surface temperature there using the symbology. So you can play with this a lot more, but what I want to do is move on to some other interesting things that we did during this process. So while we were outside at Tennessee State University, we were able to obtain the satellite match data from NASA. And so in doing so, as you can see, we were able to take our cloud observations, or well, really our cloud and surface temperature observations that we captured using during the eclipse, on the day of the eclipse, August 21st, 2017, and had those observations compare with satellite imagery that was collected at about the same approximate location at approximately the same time. So here we have 1816 universal time, 1820 universal time, and then as you can see, this wasn't a very good one because there's nothing here. Let me find a better one than that. So here's one where we observed altostratus clouds, but the satellite appeared to have lower clouds observed. Our cloud cover we said was less than 10%. But what I want to do with I'm sure some of you all did this also, but what I want to do with these images is to bring them into a story map. We'll see if I'm able to successfully do that, because it's a little bit tricky. It's tricky if you're using the free ArcGIS Online version. So the first thing that you'd have to do is take the, I'm sure you all got an email, or some of you might have gotten an email, or maybe you can get these data from some other person that collected data near you if you weren't able to, and they can share this data with you, and then you can simply save it as a JPEG, as I've done here. So these are just simply JPEG images. So that's step one. And then you will go to the log into, if you have an ArcGIS Online account, you have to be logged in, and then go to the story maps, ESRI story maps portal, or template. So what I want to do is I'm going to go to the apps in story maps, and this story map tour there's lots of different templates, but the simplest one is the story map template, and I like using story maps because it allows for your students to actually write about what they observe. So there's a writing exercise that can be built into this. So I'm going to hit build. And now here's where, like, if you have an ArcGIS organizational license, and I'm going to talk about that at the end, you don't have to go through this. You can upload them from the hard drive. But because a lot of us don't, we have to use an alternative method. So the alternative is to get a Google Plus account and then create a Google Plus profile, and then upload your images. I've already done this. I didn't even want to think about trying to do this unrehearsed. Upload your images into a folder that is public. So with the free version of ArcGIS Online, the story map, you can't upload things from the hard drive. So I'm going to show you the hard way. Maybe you can do it. Then I'll show you how to get an organizational license if you're a teacher that doesn't have one already. So I'm going to go on the apps. I've gone to Map Tour. Now, let's see, Flickr, Picasa. One of these will work. I don't know yet. So I'm going to type in if this is correct, then, well, that's probably the wrong one. Then I need to go back. This is probably the right one. TSU Globe ME at gmail.com. Okay, so it worked. Yes. So I've already uploaded my image. So now I'm going to go to this public album, which is 2517, and I'm going to hit import, and it should, there it is. So so now, if this image, if you have images that are geo-referenced, this is why aren't the images geolocated? If you have geolocated images, then they'll pop right into they'll pop right into your map. But obviously this one isn't geo-referenced. And now you just simply have to know where you are. And so I'm just going to zoom in. I'm going to keep zooming in. Keep zooming in. And this is also a good exercise for your students in map interpretation, in geography, basic geography. I'm amazed at how many students can't find the campus. So here's approximately where we were. There's Crouch Hall. This is what we call the old plaza. So we were standing about right here when we collected our data. So I'm going to go here, then I'm going to tap here, and then hit import. And so now you'll notice we have a point symbol that is at the location where we collected our eclipse data. And so you can make note of the various surfaces. So yeah, that's exactly where we were, right there, exactly. And so, you know, it's a good exercise in map interpretation. And so in terms of the writing exercise, we can click here and maybe have attribute data, perhaps Eclipse. Maybe some identifying, let's see. And then one of the, when we were at Stratford High School, we actually went to Stratford High School later on in the semester. So that's where my students took our data and compared it to the data with the for the high school students, and that was a GIS day activity. So here it is where our students went to Stratford High School, and so one of the things that I wanted to have my students do is to type what they observed at this location or what they noticed in the data. And so they might have said, well, we noticed that I'm just making it, surface and air temperatures, also spelling of following totality. Uh, 3 to 5 degrees. Let's be more precise. And then they can go on and type in other observations. The way we would make this interactive is, you know, my students would ask the high school students a question, and then the high school students would answer. And so just some and so here are my students. They're the there's Rodney Donaldson, our globe teacher, and here's the map that you just saw, and these are my students on this side of the room and high school students interacting and entering data onto the map. So we made it a really interactive exercise where the students, you know, my students were asking these high school students various questions about the eclipse and about the data. I think somewhere in here we actually have an image of the graph that was created. Where is it? Anyway, I can just show you the graph here. Well, actually, well, here are the graphs. So here is the graph that my students created using data from the eclipse that was entered into the spreadsheet, and they just used a simple Excel graphing function. And as you can see, they have the thermometer temperature here in blue, and the surface temperature in red, and over time starting at 12:27 p.m. and totality occurred at about 1:27. And so if you can just barely see how the temperatures dipped down and then they went back up, and you can just barely see how they dip and go back up as we approach totality. So it's a very good graphic representation. So we also had this graph displayed in front of the students. And if you wanted to, you could also take this graph and save it as a JPEG image, and then pull it into save it as a JPEG image like so, and then perhaps use it as an image to add to the story map, you know, if you so chose. So we could also maybe take another point here and pull that graph in also, and then have the students write what they see on the graph as it appears on the image. So I don't know how we're doing on time, but I just wanted to show everyone just one more thing. I know I kind of blew through that somewhat quickly, but I just wanted to show you just how you can take, if you've got any Eclipse data that you would like to map, you can do so. For those of you who are interested, if you are at a school for no cost, you can get the new ESRI School Maps bundle that includes an organizational license of ArcGIS Online and community analyst and lots of stuff free. If you so choose, and so I can provide the link to this resource for you so that you can do some of these mapping exercises and activities with your students using ArcGIS Online.
Yeah, and David, I don't, it says U.S. schools, so Mr. Ali is on from Trinidad and Tobago. I don't know. Do you know if it could be done internationally?
It says beyond the United States, the bundle is available to schools worldwide.
Oh, I didn't see. Okay, thanks. Yeah. There you go.
So that's thank you all for your time and attention. If there's anything you want me to go back, any questions? I saw some in the chat. I know I went through that very quickly. We only had about an hour, but it just gives you an idea of what can be done and how it can be interactive and interdisciplinary, including language art skills and map interpretation, and just all kinds of ways that you can display the data using ArcGIS. And also gives the students some hands-on experience with the software in a way that is very affordable and easy to use. Even if you're at a school, pulling ArcGIS Online on your school's computers is painless. There's no software to download or anything like that.
Right. It's you just have to sign up and then you can use it for free. So, okay, so here's Jan says, tell us what will be going on in the student follow-up on Friday. So that's a question. David, are we doing a student follow-up on Friday?
What would we like to do? Will this be a student follow-up for students?
Yes, and that's the question is, so I guess the teachers on, Steve, Susan, Deb, Mr. Ali, were you planning to have your students
what time
log
is that
in
again?
It was supposed to be 1 o'clock, and I was checking
Eastern?
with, yeah, that would be noon your time.
Yes, that's possible.
Yeah, so, and I was trying to check with Haley if they had a plan, because previous months they had like a plan, but this time it didn't seem as much of a plan. So Susan, Stephen, Mr. Ali, and Deb, were you planning to call in on Friday? It would be 1 o'clock Eastern for the student version. Okay, Susan says possible. The students really like to attend. Okay.
What we could do is perhaps try to get does anyone, I'll ask the question, does anyone who's attending have Eclipse data? Does your students collect Eclipse data that we might be able to kindergarten? Oh man, wow, I don't know.
Well, that might be tough. Yeah.
It depends. Not me as a kindergartner, but these pre-K, even pre-K kids now doing some amazing things.
Yes.
And all we did was eat peanut butter sandwiches and take naps.
Yeah, we had this little rug we used to roll up and unroll, and I think I was half day, and we still took a nap, even though I was half day. I'm not sure what that was all about. Basically, they get the kids there and then take a nap, and then go outside, and then school's over. So Susan says they didn't start taking the eclipse or data until after the eclipse, and Steve says he can't call in. But yeah, thanks, Janet. The teacher needed a break. Yes, we were bad kids.
Yeah. So if you have eclipse data, it may be possible to try to.
Well, I mean, this could be done with any kind of data, actually, from Globe.
Oh yeah.
You can basically save the data as a comma delimited file, the CSV, and then the neat thing about ArcGIS Online is it recognizes latitude and longitude in the file. And that's a fairly new thing. It happened in about the last 2 years. But before that, we used to have to specify which column was latitude, which column was longitude, and then before that, it had no clue. So you couldn't even bring the globe data into ArcGIS really. But now it recognizes it, so it's really simple. And then the student, there's all kinds of tools on ArcGIS Online. Students could do buffering. They can do different analysis with the software. So yeah. Right now we have, I'm guessing Susan says her students it's possible. And Mr. Ali, how about you? What were you thinking of calling in with students on Friday? Well, and so Susan, you don't need to get the Esri software license. You can just use the ArcGIS Online. You just have to get an account. Okay, so Mr. Ali says he doesn't. He can't do it. So I don't know. So my suggestion, David, is that we don't do the student version on Friday, okay. But that if Susan wants to follow up, she can contact. Susan's one of my teachers here in Ohio, okay. So that she can contact us and we can follow up with her. Sarah, who's on the line, she's a graduate student. She could also help. And anybody. We have used this Zoom one-on-one, and anyway, using it one-on-one, we can help students in your classroom, try things out. All right. Well, I appreciate your insights, David, and really neat the mapping you were doing with the students, and then having the high school students and the college students interacting, which I think is a really, really positive thing.
Oh, thank you.
All right. And thanks everybody for calling in, and I hope you call in. We won't have another one until January. And you'll get emails about it, and the Globe website will post the announcements for our webinars. So have a good night.